Good morning, my dear NEET warriors. Welcome aboard to the next class of your NEET 25 and NEET 26 series. And if you notice the trend in the last couple of days, in all the subjects, we have tried to cover, all the basic concepts, be it chemistry, be it biology, and even physics. So, these are the starting points of any NEET aspirant, whether you are 11th, 12th, or a dropper student. These are the topics which you need to definitely start your particular subject with. And you have seen that algebra, geometry, they are so important that you don't know when that concept will come in which chapter, probably the first chapter or even the last chapter. And similarly, we have the derivatives and the integration part, which is together called as the calculus. Derivatives, differentiation, slopes, rate, instantaneous, all these mean the same thing, related concepts. Integration, area, summing up, and so many other chapters use the formulas of integration like center of mass, etc. So if you understand what these two things are and mainly how to apply it, and at NEET level, you just need to know mainly the application part rather than how this formula comes, etc., which is important for JEE. So let's get straight away to the point and let's master these chapters, derivatives and integration, which is combinedly called as calculus. With me, your captain Shreyas. And I can see Krishna is back. All the warrior Pandus are back. Hello. Hello, White Hat. Hello, Satyashri, Meghnash, Krishna. Hello, Shruti. Hello, Saran, and all the other students. And I can see a lot of you are taking drop. Some of you are even 11th and even 12th standard students. Welcome aboard, welcome aboard, welcome aboard. And let me tell you, if you are a 11th standard student watching this, you are at the right place and you are with the right mindset, because many of your batchmates have not even started the preparation and you are already ahead of them, and most likely you will not be taking a drop. If you are a 12th standard student watching this, very good, because many 12th standard students wake up very late and start their preparation, sometimes even after boards, or probably after 2 months when everybody has gone into the race. So if you have started your journey early, you are already at an advantage. Make sure that the momentum does not break, and make sure you are following all the lectures on the Vedantu NEET English channel by subscribing and liking this video. Okay, thank you for liking. You have done that. Very good. Keep it up and subscribe to the channel. That's very important. So let's start with the derivatives first. I'll also show you the formulas and we'll see some problems. Then we'll go to integration, the formulas, and the application. Okay. So to understand derivatives, let's talk about first concept, which is slope. And when I say the word slope, imagine there is a Pandu over here. Imagine there is a Pandu over here and he is going up the inclined plane. It is very, very steep. If that same Pandu, if that same Pandu had to climb this particular inclined plane, a staircase or maybe a ramp or just a ground which is at an angle, he will be even more sad. He will be even more sad because he has to go on a steeper plane. Probably a Pandu which is going, probably a Pandu who is going on a flat ground, he will be probably okay, neither happy nor sad. Fine, his mood is okay. But if the same Pandu had to go like this, I think he will be little bit happy because he does not have to use much of energy. Gravity will do its job. And if the inclined is even more down, then he will be even more happy because the gravity will help him even more. So this is the concept of slope and steepness. Yes, Pandu and Champa is back. Yep, Pandu and Champa is back. So this is the concept of slope and steepness. So slope of anything is basically the steepness. How steep it is. How steep it is. The steepness. The steepness of that particular line, the curve, the plane, the ground, the surface below, or a graph, whatever. Okay, so that is the steepness. So this is decently steep. This is more steep. This is not at all steep. So here I would say that the slope is zero. Here the slope is basically a big fat zero. Do you guys agree with it? This is neither going up nor going down, so it is zero. Whereas over here, I would say that the slope, because you're going up, is positive. Whereas over here, I would say the slope is even more positive. because I'm going even more up. The rate is more. Here, I would say because I'm going down, the slope is basically negative, okay, with a minus sign. And in this case, the slope is even more negative. So the more down you go, more negative it becomes. The more up you go, the more positive it becomes. If you are neither going up or down, it becomes zero. Is this positiveness, negativeness, and zero concept of the slope absolutely clear? Give me thumbs up. Yes, everyone with me on this? Is this concept absolutely clear? Positive, negative, zero. Okay, taken the example of Pandu for this. So now imagine this. Let's create duplicates. Yeah. Now just imagine this. Everybody has seen graphs at some point of time or will see graphs at some point of time. So, in physics, chemistry, even probably even biology, graphs are an important part. They are an integral part of your studies, obviously. So let's say for example, my dear students, this is x-axis, this is our origin, and this is our y-axis. Okay, so this is what it is. And I have a graph drawn of something. Maybe it could be anything of some some curve, some line, etc. So for now, let's take just a line. For now, let's just take a line, or let's say we just take a random curve. Doesn't matter. Okay, it could be any curve. It could be any curve. It could be any line. Doesn't really matter, my dear warriors. I take any two random points on the curve, and I want to know between those points, how quickly am I going up or down? What is the rate of change? What is the steepness of that graph in that period, in that region? Let's say, for example, that region happens to be from here to here, from here to here. So what I will do, the first thing is, let me just go down below over here. Let me just go down below over here and go down below over here. And this I will call it as x1. This I will call it as x2. What is x1 and x2? x1 and x2 are the coordinates, x coordinates of the 2 points between which I want to find how quickly am I going up or going down, the slope, the steepness of this particular graph, whatever this curve is. They are the x coordinates of it. Everybody agrees to it. So now, between these 2 points, if I measure this distance, x2 minus x1, this whole thing is x2, this thing is x1, this is x2, this is x1. So this will be nothing but x2 minus x1, which is also called as delta x, which is also called as delta x. Delta stands for change. Once when Pandu met Champa after a long time. Pandu told Champa, there is a lot of delta in you. Champa was confused. Then Champa attended Shreyas Sir's class, and then she understood, oh, delta means change. So she asked Pandu, do you mean I have changed? Pandu said yes. So delta means change. So next time you want to put this sentimental dialogue on someone, you can say, there is a lot of delta in you. Okay? So delta means change. So from x1 I have gone to x2, there is a change. This much is the change of the x coordinate. In this region, as x coordinate changes, even the y coordinate changes. Even the y coordinate is changing, my dear warriors, right? So let's see how much is that y coordinate change. Let's see how much is that y coordinate change. Let me just drop a horizontal line like this as well as like this, and let's see. This point will be y1, this point will be y2. So the y coordinate has changed this much. So I will just show it over here like this. This much is y1, this much is y2. y2, y1, this will be y2 minus y1, the leftover. So this will be nothing but y2 minus y1, which will be delta y. The change in y, delta y. Change in x, delta x. So when x changed by so much, y changed by this much. So the manner in which I define the slope in this case will be as follows. Understand, the slope between this and this point has continuously changed by drastic amount, and what I will find will not be the slope at that moment, at that instant, or the rate of change at that particular point. Rather, it would be over a duration, over a range of values. So whatever I will find, the slope, the steepness will no longer be instantaneous. Rather, it should be average. On an average from here to here, what is the average rate at which I have gone up or gone down? I hope you guys see that. It's not instantaneous. It has to be average. So therefore, I will say average slope will be nothing but how much my y changed. So change in y coordinate upon always the vertical axis, or you can say vertical change in vertical upon the change in horizontal direction. The usual symbol of slope is m. Because I am finding average, I will put avg, which is the average slope. The symbol of slope is m. Change in the vertical direction is delta y. Change in the horizontal direction is delta x. Hence, this is the formula of your average slope. M average is nothing but delta y by delta x. Is that absolutely clear, my dear students? Yep, my warriors. Is it clear? M average, the average slope is how much the y changed upon how much the x changed. Just to give you a simple, easy peasy example over here, imagine, just imagine, just like I have drawn the graph over here, I draw a simple graph. Let's say the graph was like this, and I want to find between this point and this point, how much is the average slope. So this is obviously having 0 coordinate. Let's say this coordinate is 3 units, and over here, sorry, this is 0, maybe this is 1, this is 0, this is maybe 9 or something. Okay, and at this point y coordinate is 0, you can see. And if I go over here and I mark this point, let's say it comes out to be something like 4 or something. Just chumma, I'm giving some random graph over here. If I ask you what is the average slope between x is equal to 1 and 9, what is your answer? Let's try to find out. The average slope formula is the delta y by delta x. What is delta y and what is delta x? From here, this point to this point, can you see this much is basically delta y? This much is basically delta y. I think it is 4 minus 0, which is 4. Between this point and this point, do you see how much is delta x? It is 9 minus 1, which is basically 8. So hence, delta y is 4, delta x is 8. Hence, the answer is 0.5. Hence, the answer is basically 0.5. Is that clear, my dear warriors? Yes? Yep. I hope you see it is not 9 minus 0. Between 1 and 9. So 9 minus 1 is 8. A lot of you said 4 by 9. No, that is not the answer. It is 4 by 8. Yes, which is 0.5. Excellent. Similarly, imagine if I give you another example like this, and let's say the graph goes like this, and I take some two random points, maybe one over here and maybe one over here. Let's say this is -2. Let's say this is +5. And let's say these 2 points are at the same level, and this is, let's say, at 3. And if I ask you right now, what is the average slope between -2 and 5? Between -2 and 5, x coordinates -2 and 5. What will you do? Again, use the formula. M average is a delta y by delta x. Delta y is nothing but y2 minus y1. Delta x is nothing but x2 minus x1. How much did I go up by? Just check. Here I was at 3. Here also I am at 3. So I did not really go up at all. Yes, my delta x is there, which is 5 minus -2. But doesn't matter what is there in the denominator. Numerator is 0. So the answer is 0. From this point to this point, I have not gone up nor gone down. On an average, I have maintained my level. So the slope is 0. Everyone with me? Is this clear? A lot of people make a mistake. They say the answer is 3 by 7. That is wrong. Understand, y2 and y1 both are same. here y2 is basically 3, here y1 is also basically 3. So 3 minus 3 is a big fat 0. 3 minus 3 is a big fat 0, understand that. So it is 3 minus basically 3 again, so which is a big fat 0. Clear? Understood the concept of average slope? Pakka, so many mistakes you could have made had you not attended this class. Sir, this would be my second attempt. Very good, Mitali. So don't worry, there are a lot of students just like you, and I'm proud of you that you have taken this decision of taking a drop because you want to become a doctor, and we will support you. Make sure you are attending all the classes over here and following the instructions. I'll be making now proper NEET 2025 and NEET 2026 content. Stay tuned on the channel by subscribing and liking. Okay, great, Mitali. I'm proud of you to make this decision. Moving on. Okay, yes, Saran, I'll be doing that. Moving on now. Now that you have understood what is average slope, let's understand this concept of instantaneous slope. So, my dear students, my dear warriors, imagine some random curve. Imagine some random curve. I don't want a range between which I find the average slope. I want to find at a moment. They say, right? Live in the moment. Live in the moment. Meaning, at this instant, neither front nor back, at that moment. Meaning, the time interval is extremely small, but it is not zero. What do I mean by a moment? Can you tell me how much does a moment's value measure? What is the meaning of a moment? If I tell you, at this moment, if I ask you how much time it is, what is the time of that moment? How many seconds does it mean? Put it up in the chat box. Put it up in the chat box. Hi, Hitman. Yes, very good, Asim. Awesome. Very good, Krishna. Satyashri is also second attempt. Yes, what do you mean by the moment? Is it 1 second? No. You can have a time which is less than 1 second also. Is it 0.1 second? Well, it is small, but it is not a moment. Moment is even smaller than that. 0.001, even less. 0.00001, even less than that. I'm not talking momentum, moment of time. I mean, at this moment, living in the moment. 0.0000001. Asim is saying 0.00000000000000000000001. This is not a moment because I can always add one more zero in between and I can make it smaller, no matter how many zeros you add. So the moment which is extremely small, extremely small value of, let's say, a change is represented as, or it's called as, infinitely small value, and it is then called, let's say, delta x tends to 0, which is the same as writing just dx, delta x tending to 0, where instead of writing all these things or in the word form, you just write dx. When I say delta x tends to 0, it also means delta x not equal to 0. Delta x not equal to 0. It is very small, but it is not yet 0. I mean, it's too small, tending to 0. Understand that. Okay, you cannot write the value of this. So a lot of people think dx has a value. No, guys, understand, delta x I can write 0.1, delta x I can write 0.6, delta x I can write it as 0.00000002, delta x I can write it as 2.4 also, delta x I can write it as 1 by 1000 also. These values are permitted. Okay, but understand, I can never ever write dx as 0.00001. No, this is wrong. I do not know the value. The value is unknown. The value is basically unknown. But it is small. and not 0. That is small and not 0. That is what dx means. That is the difference between delta x and dx. A lot of you probably did not know this, so I'm making it very, very clear. So when the value becomes extremely small, I say delta x tends to 0. I represent it as dx, but dx does not have a value unlike delta x, which can be written down as a number. Okay, so this is an infinitely small value. This is an infinitely small value, whereas over here I can say this is finitely small. Finitely small. Finite means which you can measure. Infinitely means which you cannot measure. You can measure these values: 0 0.1, 0 0.6, 0 0.0002, 7, 0.4, 2.4, 1 by 1000. These are finitely small, meaning you can measure it. These things you cannot measure it. Clear? Okay. So coming back to this, at the moment, what I will do here, I'll just take two neighboring values which are separated by a very, very, very small distance. On the board, I cannot show the dx. This is highly exaggerated form. This is highly exaggerated form. Please understand it. And these are basically shown like this over here. So this particular distance between these two dotted lines is basically dx. This distance between these two particular dotted lines over here, my dear warriors, that is basically your dy. That is basically your dy. If you zoom onto it a little bit, if you zoom onto it like heavily, you will see that that particular curve is actually a straight line because you have taken a small part of the curve. Think about it. Any curve, if you say, any curve, if you see, you will see that it is made up of small straight lines. You might have played with the railway tracks, or you might have played with some pins or some sticks or some matchbox, those matchsticks and all that. You arrange those matchsticks in a funny manner or in a curvy manner. You can see from the distance it looks like a curve, but if you see in reality, it's made up of small straight lines. So if you zoom onto it over here, my dear students, you will see a nice little straight line over here, nice little straight line over here. And these two dotted lines are like this, and these two dotted lines horizontally are basically like this. So hence, this distance, how much will it be? This distance, how much will it be? It will be dx. And this distance, my dear warriors, this distance, how much will it be? It will be nothing but dy. And you are getting a nice little right angled triangle. You are getting a nice little right angled triangle. In fact, I will also mark this particular angle as theta. I'll mark this particular angle as theta. Okay. So you will be seeing that there is a use of this theta in the later on. Till this part, everybody is clear? Till this part, everybody is clear? Okay. Now, what I will do is, because it's a straight line, if I extend it on both sides, like this and like this particular line will then become the tangent. This will then become the tangent. Your curve might go anywhere. It could be like this. Your curve could go anywhere. But if you extend that line at that instant, that's it. It is going to become the tangent. So I can just draw a beautiful tangent right over here. Maybe something like this. Okay. So this is our tangent, which I have drawn. Okay. This is the tangent. This is the tangent to the curve, Whatever angle the tangent makes with the x-axis, if I mark it as theta, don't you think, don't you see that the same angle theta will be also over here? Because if you draw a horizontal line, even this will be theta. Two parallel lines, these two angles are always congruent. So do you see that if this is theta, even this is also theta, or if this is theta, this is also theta. Till this point, everybody agrees? Give me a thumbs up. Till this point, everybody agrees? Everyone? Everyone? Okay. Okay. Very good. Very good. Very good. Awesome. 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 Clear? Okay. Very good. Okay. Now, if I ask you, what is the instantaneous slope? Remember, for average slope, the symbol that I used was m average. For instantaneous, I don't have to use any symbol. I just leave it as m. So this then becomes the instantaneous slope. So instantaneous slope, instantaneous slope will be small change, small delta in vertical upon a very, very small change in the horizontal. So that is represented by m. That small change in the vertical in this case is nothing but dy, and the small change in the horizontal is nothing but dx. But the best part, if you look at this triangle, dy is opposite, dx is adjacent for theta. So hence, is it not tan of theta? Is it not basically tan of theta, my dear students? That's it. So instantaneous slope is represented as dy by dx, not delta y by delta x. That is also tan of the theta. Theta is angle made by the tangent with the horizontal line. Theta is the angle made by the tangent with the horizontal line. You might be wondering, sir, can I cancel this d and d? Very good. Nice thought. Then tell me, why did you not cancel delta over here? If that is the case, why did you not cancel delta? Reason is delta is not a variable. Delta is a function. It's an operator. It's an operator. Then you will do all random things in life. Like for example, somebody will say, sir, sine of x by tan of x. Sir, n and n will cancel. X and x will cancel. Sir, it is psi by ta. Psi by ta. You can do all these things. Understand, sine is not s into I into n. It is a operator. Okay, it's a function. So same way, delta d is an operator. You cannot do those kind of random things over here. Correct? Very good. Now, another interesting thing. This dy by dx, this dy by dx is called as the derivative of y with respect to x, one way of writing, or you can also call it as differentiation of y with respect to x. Then you can also call it as of change, rate of change of y with respect to x, or you can just call it dy by dx. All these things mean the same thing. All these things mean the same thing. You can also call it, I don't have space, so maybe I'll just write it over here. This was dx. You can also call it the slope, the slope of the tangent to the curve, of the tangent to the y-x curve, y versus x graph. Okay, all these things mean exactly the same thing. Now let's take numerical problems to understand this. Let's take numerical problems to understand this. First of all, tell me, do I know the value of dy or dx? Can I measure that value? No, right? I hope you remember. I told you some time back, they are infinitely small. They are unknown. You cannot tell me the values. They are immeasurable. So a lot of you might have also thought, how the hell are we going to measure this ratio? Because dy value, if you ask me, I don't know. Dx value, if you ask me, I don't know that. But then, how do you measure dy by dx? Numerator, don't know. Denominator, don't know. Numerator by denominator, I know it. How? Tan theta. If I draw a tangent, measure the angle, I can get the value. That is the funny part about derivatives. That is the interesting part about derivatives, that in spite of not knowing numerator or denominator, I know the value of numerator by denominator by finding the tan theta value. So let's take examples so that you understand this. Say for example, I take a random graph like this and show it like this. And let's say, maybe at this is x is equal to 2. I want to find what is the slope. I want to find what is the rate of change. I want to find the derivative. So at that particular point, I'll just go up, and at that point, I'll just draw a tangent. I'll just draw a tangent. I will measure this angle. Let's say I found out the angle comes out to be 60 degree. So my dear warriors, if I ask you, what is the slope? What is the slope at x is equal to 2, which is basically dy by dx. I don't know dy or dx, but I know the tan of the angle made by the tangent. So tan of 60 degree, tan 60 is nothing but root 3. So hence the slope will be approximately 1.73. So that is the slope at x is equal to 2. We got this answer. We got this answer by drawing the tangent. Interesting, isn't it? Similarly, let's say somebody asks you, what is the slope at x is equal to 0? You'll be like, okay, it is again dy by dx, but you have to go at x is equal to 0. X equals to 0 is over here. This is the origin. Go down here at this point. If you draw a tangent, it is like this. What is the angle made by the tangent with the horizontal? 0. So it is actually tan of 0. Hence the slope is 0. So the slope at x equals to 0 is 0. The slope at x equals to 0 is 0. Is this absolutely clear, my dear students? Yep, very good. Similarly, somebody tells you, hey, listen, I want to find the slope at maybe, I don't know, at x is equal to minus 1, as x is equal to minus 1. So you go down here, and at this point, let's say you draw a tangent. And it so happens this makes an angle of 45 degrees. 45 degrees with the horizontal example. Okay. So now you have been asked, what is the slope at x is equal to minus 1, which I know is tan of this angle, but be careful, it is not up, it is down. So even if you write tan of 45 degree, I have to put a minus sign. Why this minus sign? It is down. Actually speaking, it is tan of minus 45 degrees, because understand this concept. If I'm taking this as the horizontal, all the angles which I go here will be positive, whereas all the angles which I go down over here will be negative. If I'm going down, this will be negative. If I'm going up, that will be positive. So actually it is minus 45. But do you remember that rule? Tan of minus theta is minus tan theta. It is actually minus of tan theta. So it is basically tan of 45 with a negative sign, which is minus 1. Hence the slope at x is equal to minus 1 came out as minus 1. It came out as negative 1. That's how it is. Okay. Is that clear? Okay. Everyone with me? Everyone with me? Okay. Okay. Great. Come on, come on, come on, come on. Come on, come on. Yes. Let's go ahead. Shivani, Mitali, concentrate on the class. Concentrate on the class. Yeah, don't waste your time doing random time pass. Come on, focus on the class. Okay. Now that you have understood it till this point, you might be wondering, sir, every time the question won't be graphical, no, sir. Every time the question won't be graphical, no, sir. Like, fine, this is graphical, then we can draw the tangent, we can get the slope. Sir, what if the question is not graphical? So then we go to the analytical method. Then we go to the analytical method, and let's see what is the analytical method. In fact, it is very, very simple and straightforward. Imagine, imagine you are not given the graph. You don't know the graph. When graph is unknown or not feasible or not feasible, or equation is given, equation is given, equation is given. Say for example, y is equal to x cube. I know y is equal to x cube. The graph, if I draw it, fine, it will look like this, but drawing it will take time, and plus it should be accurate. Or if I do not draw it properly, all right, if I make some mistake in that, then when I draw the tangents, it might have some error in it. The angle will be a problem. And what if the angle is not a standard angle, like tan of 50 degrees, tan of 47 degrees? You cannot do all those things. So that is the reason why we need to go with next method, which is the analytical method. Then what you do is we go with the analytical method. Analytical method. Analytical method. When equation is given, graph is not given, graph is unknown, not feasible to draw it, or there might be some error, all these problems. So then we go to the analytical method. So in analytical method, what happens is you are given a function. You are given, you are given a function. You are given a function. What is function? Function means you give me X, I will tell you Y. You give me something, I will give you the output. You give me the input, I'll give you the output. So a function is like a magical box. A function is like a magical box where you give in some input, for example, let's say X, and you get an output. You get an output, which is, let's say, Y. It is represented like this. Y is some function of X. Y is some function of X. For example, I tell you that if I give the input as 1, I get output as 1. If I give the input as 3, I get the output as 9. If I give the input as 0, I get the output as 0. If I give the input as 2, I get the output as 4. If I give the input as 5, I get the output as 25. Can you guess what this function is? Can you guess what this function is, my dear students? Yep. Can you guess what this function is? What is this? Yep, it is a square function. So my y is just x square. Y is just x square. So squaring is that function, because whatever number you give, it is squaring it and giving. So that is that magical box. That is that magical box which is just squaring it and giving it. Exactly. So that is the meaning of any function. If I know the function, then my God, what just happened? If I know a function, then 100% that function will also have some graph, which I do not know, how it will be, but some graph will be there. Some graph will be there. Okay, I'm just showing some random thing. If I want to find the derivative, that means I basically draw a tangent, and this is theta, this is the tangent to the curve, and all of that. If I want to find the derivative, that means dy by dx. It is also represented as f dash of x. When I put f dash, that means I have taken the derivative. I have found the slope. I am finding the rate of change. I am finding the differentiation of that particular graph, that curve. I am drawing a tangent and measuring the tan theta. That is basically tan of theta, but I cannot measure theta. So there is a process. There is a process, or there will be a process, or basically there is a formula which will give me the answer. If this works, good. If this doesn't work, then use the formula. So we are going to see what those formulas are. We are going to see what those formulas are. Is this clear, my dear students? Is this absolutely clear? We are trying to find the derivative, which is also represented as, shown as symbolically, f dash x, which is also tan theta. Some books also use this symbol. They will call it as y dash. Y dash, dy by dx, f dash x, all of them mean the same thing. Don't get scared. They are all exactly the same thing. Cool? Yes, very good. So what is that formula? You will be surprised to see how simple our job becomes. How simple our job becomes when you use that formula. The formulas are as follows. If the functions, I'll show the functions over here, and then I will show what is the derivative over here, which is f dash of x. Very, very important. So if the function is basically, x raised to n, then the derivative of that function, the dy by dx of that function, is nothing but nx raised to n minus 1. Basically, what I'm trying to say over here is if you differentiate this, okay, what you get is n into x raised to n minus 1. Derivation you don't bother, don't care. Only in JEE Maths it comes, in JEE Physics also it does not come. So don't worry about it. Similarly, if you have a constant function, then the derivative, then d by dx of that constant comes out as 0 because it's a constant, it is not changing at all. So it should be 0. Think about it, it's very logical. Similarly, if my function, is e raised to x, e is that, that natural number 2.7, right? So then the derivative of e raised to x, comes out actually as e raised to x only. This is the interesting part. E raised to x does not change, it comes out as it is. Similarly, if I have log of x, ln x, then the derivative of d by dx of ln x comes out as 1 by x. Continuing this process further, I'm just giving you some basic formulas. We are going to see the application of it. Don't worry. Just for now, look at the formulas. If it is basically sine of x, then we can also go to cos of x and all of that. Just showing you some basic formulas. Sine of x's derivative, d by dx of sine of x, is basically cos of x. Derivative d by dx of cos of x is negative sine of x. So these are some standard, most commonly used derivatives, my dear warriors. Most commonly used derivatives. This is the starting part. Let's understand it. In fact, there are many formulas. I think I have put it somewhere over here. Okay, where is it? See, derivative of x raised to n, derivative of sine x, derivative of cos is minus sine, derivative of tan is sec square, derivative of cot is minus cosec square, derivative of sec x tan x. Okay, derivative of cosec x is cosec x cot x, derivative of e raised to x is e raised to x, derivative of a raised to x is a raised to x log x, derivative of log of x is 1 by x. These are the formulas which you need to know for NEET physics. That's it. Don't worry about this right now. For this, this is the most important formula list. Okay. Now let's understand what do I exactly mean by this. Imagine. Let's take an example, my dear warriors. Only through examples you're going to understand it. For a moment, take a screenshot, write it down on a piece of paper. Write it down 2 times. I'll give you 1 minute. Write it down. All these basic formulas, write it down 1 or 2 times. Let it enter your head. Let it enter your head. Even if you're watching this recorded, just write it down. Within 1 minute, these formulas again and again. Only the orange part. Even if you don't write the yellow part, it is okay. At least the orange part. Derivative of x raised to n, nx raised to n minus 1. Derivative of constant, 0. Derivative of e raised to x, Derivative of ln x, 1 by x. Derivative of sin x is derivative of cos x. Derivative of cos x minus sin x. Just write down this at least 1 to 2 times. Done, written. Okay, perfecto. Now that it is there in front of you, because I won't be going back to this slide. All right, so let's see what the problems will look like. Example. Let's say I want to find derivative of x cube. First of all, understand this is of the form x raised to n. So here this number 3 is like that n. So what happens is that n comes outside. Which is basically 3. And what remains inside is n minus 1. You see, n minus 1 power remains inside. So this will become 3 minus 1. So hence this will become 3x square. That is the answer. Now you'll be like, okay, sir, what is so magical about this? See, I don't know how the graph looks like, but if the question asked you, what is the slope? What is the slope? What is the slope at x is equal to 2? Then all you are going to do is, I found out the value of the slope over here. If you notice, this is the slope, which is 3x square. So the slope at x is equal to 2 will be, substitute x as 2. So 3 into 2 square. 2 square is 4. 4 3 is a 12. That is the answer. 12 is the answer. You don't have to draw a graph. You don't have to find the tan. You don't have to find the cos. Nothing. Directly you got the answer by using the formula. That is what I was mentioning over here in the analytical method. No need of graph or anything. Only if you know the formula, you will directly get the derivative, which is the slope of that particular graph. So that's it. Let's take more examples so that you are very super duper confident about this. Super duper confident about this. Okay. Next example, my dear warriors. Find the slope of y is equal to sine x at x is equal to pi by 3. That is the question. X is equal to pi by 3. First of all, this is the function. If I want to find the slope, which is m, I have to find dy by dx. Here, y is nothing but sine of x. Y is nothing but sine of x. What is the derivative of sine x? I just showed it to you. Sine x's derivative is cos x. Sine x's derivative is cos x. So the answer is basically cos x, but you cannot leave the answer like that. I have to substitute x is equal to pi by 3. Substitute x is equal to pi by 3. What is pi by 3? Pi by 3 is basically 60 degrees. Cos of 60. What is cos of 60? It is basically half. Hence, the answer is half. Hence, the answer is half. As simple as that. Right? Let's go to the next question, my dear warriors. On your screen now. Find the slope at x is equal to 5 for y is equal to ln x. Y is equal to ln x. That is the question. Y is equal to ln x. First of all, if I want to find the slope, means I have to find dy by dx. That means I have to find the derivative of ln x. Instead of y, I have put ln x. What is the derivative of ln x? I just showed it to you right over here. It is nothing but 1 by x. It is nothing but 1 by x. So just put 1 by x. But I have to put the value of x as 5 in the end. So 1 by 5 is the answer. That's it. The value of the slope is 1 by 5. Isn't this method much simpler? Without drawing tangents, without drawing or measuring angles and finding the tans? Yep. Very good, Krishna Meghna. Awesome, Satyashri Baswaraj. Very good, Savita. Very good, Meghna. Awesome, awesome, awesome. Kudos to all of you. Now, let's proceed ahead. Let's take more examples to find the derivative. Hold on. Let me just get rid of this. Okay, let's see if you guys can find the derivative of this quickly in the chat box. Derivative of x square is how much? Next question. Derivative d by dx of x raised to 70 is how much? Next question. Derivative of root of x is how much? Next question. Derivative of x is how much? Okay, chalo, figure this bit out for all these questions. Come on, my dear students, it's not that difficult. Try to solve these questions. 4 questions on your screen. First question, I'm pretty sure you would have figured out. 2 is basically that n over here. So that 2 will come outside, and what will be remaining is x raised to 2 minus 1. 2 minus 1 is 1. So it will be just 2x. So answer is 2x. Let's see how many of you wrote it. 2x. Very good, Meghna. Very good, Krishna. Awesome, Baswaraj. Very good, Satyashri, Sara. Excellent. What about this? 70 will come outside, and this will be x raised to 70 minus 1, which is 70 x raised to 69. Perfect. Many of you got the answer as well. Very good. Proud of all of you. What about this? Well, I can write this as the derivative. Root means x raised to half. So that half comes outside. X raised to half minus 1, which is half into x raised to minus half, which is 1 by 2 by x raised to half below, which is 1 by 2 root x. So answer is 1 by 2 root x. I've done it stepwise. Root x is x raised to half. That half comes outside, half minus 1, power will be reduced. So half minus 1 is negative half. Negative power means I can bring it down. X raised to half is root. So root x below with the 2. That's it. That is the answer. Very good. If you guys got it, proud of all of you. What about the last one? What about the last one? This is the same as saying derivative of x raised to 1. So that 1 will come outside into x raised to 1 minus 1, which is basically 1 into x raised to 0. X raised to 0 is also 1. So the answer is 1. Answer is 1. Yes. Got it? Everyone? Let's proceed to next few problems coming up on your screen. Find the derivative of d by dx of 1 by x. How much it is? Next question. Find the derivative of 1 by x raised to 3. How much it is? Next, find the derivative of x raised to 0.8. How much it is? These are the 3 questions. 3 next questions. Come on, figure this bit out. Everyone with me on this. Let's see the first one. X is below, don't do anything. Now take it on the top. Always write it in the power form. D by dx, always bring the powers on the top. It will become x raised to minus 1. Now write it properly. It will be minus 1 into x raised to minus 1, which is minus 1 into x raised to minus 2. So I can just write it as negative 1 by x square. Negative 1 by x square. X square will come below. Very good. Excellent. Proud of all of you. How about this? Bring that cube on the top. So it will become derivative of x raised to minus 3. Okay, so this will just become minus 3 into minus 3 into x raised to minus 3 minus 1, which is minus 3 into x raised to minus 4, which is as good as saying minus 3 divided by x raised to 4. Minus 3 divided by x raised to 4. Is that clear? Yep, everyone? Got it? Kudos. How about this? Take that 0.8 outside. Take that 0.8 outside. It is into x raised to 0.8 minus 1, which is basically 0.8 into x raised to minus 0.2. If you want, you can write it as 0.8 divided by x raised to 0.2. X raised to 0.2. That also you can write it. Okay? This is how you solve these questions. Let's do one more question, one last question, maybe. Let's see if you guys can figure this out. Find the derivative of 1 by root x. Come on, let's see how many of you can do it the quickest. I want to see the answers being spammed in the chat box as soon as possible. Last question on your screen before we take up many other rules. Okay, before we take up other rules. Come on, my dear students. Yep. Come on, everybody. Very good. First thing what you will be doing is take that root x on the top. In fact, it will be d by dx. Root x means x raised to half. X raised to half, but it is below. When you go on the top, it will become negative power. So x raised to minus half. So minus half comes outside. X raised to minus half minus 1, which is minus half. X raised to minus 3 by 2. Negative power, I can bring it below. So minus 1 by 2 raised 2 into x raised to 3 by 2. That is the final answer. Minus 1 by 2 into x raised to 3 by 2. That is the correct answer. Yep. Be careful. Satyashri made a mistake, I guess. Check this out. If you guys got this answer, kudos if you got it right. Very nice. Very nice. Shall we move ahead to the next one? Shall we move ahead to the next one, guys? Okay. Now, the next set of rules which are going to come. The next set of rules which are going to come. All right. Now, there are many rules in derivatives which we are going to see. Okay. Once you learn these rules, it becomes very, very simple. It becomes very, very simple, easy peasy. So, what are the rules? Let's have a look. So, the rules in derivatives. The rules in derivatives. Okay, some of the formulas. The first formula which you should know is when I want to find the derivative of some function, and let's say it is k into x, okay, k into x, sorry, not that k here, that k is here, k into f of x, then you can take that k outside and then find the derivative as it is. Then you can find the derivative as it is. Okay, so just 1 second. Let me. Okay, so this is the first rule of the derivative. Let me show it to you by an example. Imagine I want to find the derivative of 5x squared. This 5 is like that constant. You can bring it outside. So it will become 5 into just simply the derivative of x square. So which is basically 5 into x square's derivative. Take that 2 outside. X's power, reduce it by 1. So it will become 2 5s are 10. X's power will just be 1. So the answer is 10x. Similarly, if I want to find the derivative of cos of x, sorry, 6 cos x, 6 cos x. What I can do is bring that 6 outside. So it will become just the derivative of cos x. 6 is outside. So derivative of cos is basically minus sin x. So the answer is minus 6 sin x. That is the answer. So this is that simple rule. If there is a constant being multiplied, take that constant outside, the derivative, and do the derivative process normally. That is the first rule. The next rule that you have the next rule that you have is this one. Imagine you have a functions being added or subtracted to other function, being added or subtracted to, let's say, some other function. Then when you want to find the derivative of that entire thing, you can find the derivative separately and then add or subtract it. So it will be just d by dx of f of x plus minus anything into d by dx of g of x. As simple as that. Let me show this to you by some examples. Say for example, you want to find the derivative of sine of x plus ln x. Okay, you want to find the derivative of sine of x plus ln x. You find the derivative of sine of x separately. You also find the derivative of log of x separately and add them. So sin x's derivative is just cos of x. Log x's derivative is just 1 by x. That is the answer. Another example which I can show you. Imagine I want to find the derivative of x square minus sine of x square minus sine of x. What you will do is just find the derivative of x square separately and also find the derivative of sine of x separately. Derivative of x square will be 2 into x raised to 2 minus 1, and sine x's derivative is just cos of x. So it will just become 2x minus cos of x. 2x minus cos of x. Is that clear, my dear students? Yep. Very good. 2x minus cos of x. Perfecto. Perfecto. So this is how you use the addition subtraction rule. The next rule that you have is the multiplication rule. The next rule that you have is basically the multiplication rule, and then you have the division rule. So let's come to that. So multiplication rule, derivative of f into g, some function into some other function. What you will do is, you write down the first function as it is, multiplied by the derivative of the second function, plus write down the second function as it is and write down the derivative of the first function. So g dash means the derivative. If I do not put dash, it is as it is the function. So let me demonstrate this to you by an example over here. Imagine I want to find the derivative of sine of x into ln x. These are two functions. Sine is f, g is ln. So what I will do, I'll write down the first function, which is sine of x as it is. Derivative of the second function, d by dx of ln x, plus second function, which is ln x as it is, derivative of the first function, derivative of basically sine of x. That's all. So, my dear students, what will happen is sine of x into, what is the derivative of log x? It is just 1 by x. then plus log of x into, what is the derivative of sine of x? Well, that is cos of x. This is the answer. This is the complete answer. Cool. Let's take another example, my dear students. Imagine I want to find d by dx of e raised to x into x raised to 4. X raised to 4. These are two functions which are being multiplied. This is f, this is g. So write down the first function as it is, the derivative of the second function. Then the second function as it is, derivative of the first function. E raised to x is coming as it is. X raised to 4's derivative is nothing but 4x cube. 4's power will reduce by 1, will become 3. The next term will be x raised to 4. And what is this? Derivative of e raised to x is e raised to x only. So it will just be e raised to x. It is just be e raised to x. If you want, you can take out a few terms common, like x cube into e raised to x is common, and here you will be left with 4, and here you will be left with x. So that is the final answer. Yep. Everyone clear about this? Clear about this concept? How to use product rule? Okay, we have seen, if there is a constant, bring that constant outside. Addition, subtraction, separately you do the addition, subtraction. Multiplication, first function, second derivative, second function, first derivative. First, second derivative, second, first derivative. As simple as that. Now comes the next rule, which is the quotient rule or the division rule, which is the division rule. So if I have d by dx of f by g, one function by another function, what you do is, first of all, you put the denominator square, okay, and then you write it down like this: g f dash minus f g dash. That is it. Second function, first function's derivative minus first function, second function's derivative divided by the square of the denominator. As simple as that. Okay, let's take an example to understand this. This is simple formula. So let's say we take, I want to find, let's say, derivative of tan of x. Now remember, tan of x's derivative, I can find it directly using the formula, but using the division rule also I can do this. I can write it as sine of x by cos of x. Here sine is f, g is cos. So first things first, in the denominator, put denominator square. So it will be cos square x. In the numerator, the denominator first. Always start with the denominator. Then the numerator. Numerator is sine. So derivative d by dx of sine of x minus numerator, which is sine of x, into denominator's derivative, which is cos x's derivative. Let's see what do we exactly get over here. Okay, so cos x into sine x's derivative is again cos of x only, minus. This is sine of x, and cos x's derivative is minus sine x. So divided by cos square x. This is nothing but cos square x. Minus minus will become plus. So this will become sine square x. Whole thing divided by cos square x. Interesting. Sine square plus cos square is 1. So it will become 1 by cos square x. 1 by cos is sec. So this will become sec square x. That is the answer. So derivative of tan x is sec square x. We got it using the quotient rule or the division rule. Okay, clear? How to use the division rule, how to use the multiplication rule, how to use the addition rule, subtraction rule, and what to do if there is a constant. Just bring that constant outside. Just bring that constant outside. Okay, so many things we have seen. Next rule is going to come up on your screen now. Next rule is going to come up on your screen now. Let's see what that next rule is. This is called as the chain rule. This is called as the chain rule, used in many problems. In fact, before going to the chain rule, let me show you another rule. If derivative of f of x is, let's say, g of x, then derivative of f of ax plus b, this is also called as ax plus b rule, ax plus b is g of ax plus b, but that a will come outside. But that a will basically come outside. That's all. So this is called as the ax plus b rule. Let me demonstrate this to you with an example. Imagine I want to find the derivative of sine of 3x plus pi by 3, okay, or pi by 4, something like that. This is sine's derivative, but not sine x's derivative. There is some ax plus b. Do you see that ax plus b form is there? So whenever you see ax plus b form, use this method. What does this method say? If derivative of a function is something, you find that derivative, just multiply it with the coefficient of x. What is the derivative of sine? Cos. So just simply write cos of 3x plus pi by 4 like you would do normally. But multiply this entire thing with the coefficient of x, which is basically 3. So this is the answer. That is what this means. That is what exactly this means. Understood? Let's take one more example. Don't worry. Imagine I want to find the derivative of log of, let's say, 2x minus 3. What will you do? Usually you know the derivative of log x, but instead of x you have ax plus b form. So okay, what is the derivative of log x? 1 by x. So normally do the mathematics, so it will be 1 by this entire term. Treat this only like x. Treat this entire thing by x. So 2x minus 3 will come below. What is the coefficient of x? It is 2. So multiplied by 2. Hence the answer will be 2 divided by 2x minus 3. That is the answer. That is the answer. Got it? How to use this rule? Many teachers, many books might be writing this, but you need to understand it also. Some people try to skip this and try to do this via chain rule. I do not appreciate chain rule every time. Instead of chain rule, use this ax plus b rule. Makes your job very, very simple. Life is easy with this. We'll be solving more problems. Don't worry about it. I just told you the rules first, then we'll go to mixed problems. Sixth rule is the chain rule. Sixth rule is basically your chain rule. What is this chain rule? What is this chain rule? Okay, let me tell you this. Chain rule, actually first let me write it down, then I'll explain with an example. If you have dy by dx, that can be written down as dy by dt, any variable, dt by d, let's say a, into dA by dz into dz. It's up to you when you want to stop. Let's say I decide to stop now, then stop it over here. Notice one thing. This was, let's say, dy. Let's say this was dx. dy is only there over here and dx is only there over here. Rest everything else is like a chain. Rest everything else is like a chain. The first term is here, the last term is here, and after that what you have is a chain. You go down like this and go here like this. Go down over here like this, go over here like this. Go down over here like this, go over here like this, and you can stop at any given point of time. So there is like a chain of events which are happening. If you divide by time, multiply by time. Divide by a, multiply by a. Divide by z, multiply by z. Anyways, it cancels out. What is remaining is just dy and dx. This is basically called as your chain rule. As simple as that. Now, how to use chain rule? What are the typical applications of it? Observe this carefully. Observe this carefully. Imagine a situation. Imagine a situation like this. I want to find the derivative of sine of x, but with respect to t. Please understand, you cannot differentiate this. You cannot differentiate x with time. If there is x, there should be x. If there is t, there should be t. This, you cannot write it as cos of x. It's invalid. It is invalid. Understood, my dear students? It is invalid because you are differentiating x with respect to time. Oh, so what to do? Use chain rule. This is like y, this is like x. What I can write it down as, is derivative of sine of x. Differentiate it with respect to x. This I know. Because I divide by x, I have to multiply it by the same thing. and dt, just leave it as it is. Leave it as it is. This value I can calculate. So derivative of sine of x with respect to x is cos of x. Dx by dt, I leave it as it is. Later on in physics, you will learn that dx by dt is actually velocity, and then you can write it as v times cos x. Okay, derivative of x with respect to time is velocity, and immediately you will convert it in that form. So that is how you use chain rule in problems where the variable with respect to which you are differentiating only is completely different. The variable only is completely different. Okay, clear? Shall we go ahead? So these are the basic rules. Let me just put them up for all of you as a slide over here. Just take a moment to look at all the rules over here. Just take a moment to look at all the rules over here. Okay, all these rules are here. Derivative of constant, derivative of uh, addition, subtraction, then constant, product, quotient. These are standard rules. Then the formulas are mentioned over here. X raised to n x raised to n minus 1, sin x, cos x minus sin x, tan x, sec square x, cot x minus cosec square x, sec x tan x, cosec x minus cosec x cot x, e raised to x, e raised to x, a raised to x, a raised to x log a, log x 1 by x. Okay, just take a moment to write down these formulas. These rules, we have done it already over here. No need to write it down. Just write it down in your book once. 1 to 2 times at least write it down. I'll wait for a moment. I'll wait for 1 to 2 minutes. What is the derivative of x raised to n, sin x, cos x, tan x, cot x, sec x, cosec x, e raised to x, a raised to x, log x? These are the only derivatives you need to know. No need of inverse trigonometry and complex things. That will not come. That will not come. Okay, just take a moment, write it down quickly. We'll start with problems. We'll start with many questions now. Done? Give me a thumbs up, smash the like button if you're done with it. Okay. Very good. Chalo. So if this is done, all these rules are taught to you. Let's apply these rules, only then you will understand it. Okay. Let's apply these rules. Okay. Let's start with some examples. Here it comes on your screen. If you want to find the derivative of 3x minus 4 raised to 6, what is the answer going to be? What is the answer going to be? Okay, just try to think about it, my dear students. Okay, this is of the form ax plus b. This is of the form ax plus b. Treat that 3x minus 4 as a single variable. Imagine, had there been x raised to 6, what would you do? X raised to 6 as derivative. You would have written down 6 into x raised to 6 minus 1, which is basically 5. Which is basically 5. That is what you would have written it down as. Do the exact same thing. You know the derivative of anything x variable raised to some number. It is that number multiplied by that variable which is there into 6 minus 1. So it will be 3x minus 4. But since it is ax plus b form, this is that important part 3, which is the coefficient of x. You have to multiply that 3 over here. You have to multiply that 3 outside. So hence the answer will be 18 times 3x minus 4 whole raised to 5. That is the answer. That is the answer. 18 times 3x minus 4 whole raised to 5. Very good if you guys got it. Proud of all of you. Let's go to the next question coming up on your screen. Find the derivative of ln x with respect to t. Find the derivative of ln x with respect to t. Let's see if you guys can figure this out. First of all, I don't think I can proceed directly because the moment I see x and time over here, I should be very careful. I cannot do that derivative, so I will use chain rule. So d ln x by dx, okay, into dx and then divide by dt. This is okay. This, forming a chain. Perfectly fine. So hence the answer for this question will be derivative of log of x is 1 by x into dx by dt. Just leave it as it is over here. Just leave it as it is over here. Very nice. Let's go to the next question coming up on your screen. Let's go to the next question coming up on your screen. How about derivative of sine of x square? Sine of x square with respect to x. Think about it. I cannot find the derivative of x square with respect to x also because I only know if inside is x, denominator also should be x. If this is x square, this should have been x square. Only then it would work. Only then it would work. Yes or no? So I will make it work by deliberately putting x square without changing the equality. How? Look at this. Sine of x square with, sorry, I had to put d over here. I think that d was missing. My bad, guys. Yeah. So that d was missing. So what I will do is derivative of sine of x square with respect to dx square. I have to also multiply to preserve the equality and then keep that dx from here as it is. Does this look like chain rule which we have used? With respect to x square into x square dx, I have preserved the equality. So now what will happen? I know the derivative of sine of anything with respect to the same thing. It is nothing but cos of that same thing. So it will be cos of x square. Do you guys agree? The first term, if this was y, this is also y. This is s, this is s. This is x, this is x. So same things I can differentiate. So derivative of sine is cos. Whatever was there inside the bracket, put it as it is because differentiation was with respect to the same variable. What is derivative of x raised to 2? Well, use x raised to n formula. It is 2 into x raised to 2 minus 1. So hence the answer will be 2x into cos of x square. 2x into cos of x square. Got it? Everybody with me? Excellent. Let's go to the next question. Let's go to the next question. If you understood it till here, just look at the problem. Take a moment to appreciate how these kind of questions have to be done. Next question coming up on your screen. Find the derivative of 1 plus x minus 1 by x. Come on, let's see if you guys can figure this out. 1 plus x minus 1 by x. You have to figure out the derivative of this. There are three terms. So I will split up the derivative and then find the derivative individually and add and subtract them. So I'll find the derivative of 1 separately, find the derivative of x separately, minus d by dx. X is below, so bring it on the top. So it is x raised to minus 1. Derivative of any constant is always 0, so don't even worry about it. Dx by dx cancels, it becomes just 1, minus, here this minus 1 will come as it is, into x raised to minus 1 minus 1. That's it. So this will become 1 minus minus plus x raised to minus 2, which is 1 plus 1 by x square. That is the answer. 1 plus 1 by x square is the answer. Very good, Satyashri. You are very quick in this. Proud of you. Very good. Let's move on to the next question coming up on your screen, my dear students. Come on, let's do this. Find the derivative of 6 sine x into x raised to 6. Okay, just try to find the derivative of 6 sine x into x raised to 6. You can see there are two functions being multiplied with each other, two functions which are multiplied with each other. So you have to use the product rule. Also, you see one constant outside, bring that constant outside and do the rest of the things. So 6 as it is coming outside. First function into the derivative of the second function plus the second function into the derivative of the first function. That's it. So let's see, what do we get? Sine x as it is, derivative of x raised to 6, x raised to n formula, 6 into x raised to 5 plus x raised to 6 as it is, derivative of sine of x is just cos of x. That's it. If you want, you can just take, x raised to 5 as common, 6x raised to 5, and then bracket, you will have 6 sin x, 6 sin x plus x cos x. That is the final answer. That is the final answer of this particular question. Very good. Excellent. Similarly, let's say, for example, you have another question like this. Y is equal to y is equal to t raised to 5. X is equal to sine of t. Question is, find dy by dx. That is the question. Very interesting question, very different kind of question. How are you going to solve this? Y is a function of time, x is a function of t. Find dy by dx. Don't get scared. I'll tell you what. This is again an application of chain rule only indirectly. You can do one thing. You can do dy by dt in the numerator and you can do dx by dt in the denominator. Dt will anyways cancel. It's like chain rule only. Dt will anyways cancel, and this can be done separately. How? I just have to find dy by dt. What is y? Y is t raised to 5. Dx by dt, what is that x? That x is basically just sine of t. So evaluate numerator and denominator separately. That's all. Evaluate numerator and denominator separately. T raised to 5's derivative is 5 into t raised to 5 minus 1. Sin t's derivative is basically cos t. Hence the answer will be 5t raised to 4 divided by cos of t. Divided by cos of t. That's it. That is the answer. Got it? Let's do one more question coming up on your screen. Yes, let's do one more question, my dear warriors. All right, just 1 second. Y is equal to z square and x is equal to root of, sorry, it is nothing but, let's say, ln z. Question is, find dy by dx. That is the question. Find dy by dx. Come on, let's see if you guys can figure this out. It's again very similar to the previous question. Dy by dx, y is function of z, x is function of z. Think about chain rule. Think about chain rule, my dear students. Okay, so if I want to find dy divided by dx, divide y with respect to z and divide x again with respect to z. Evaluate numerator and denominator separately. So this will be d by dz. This will be d by dz of y. Y is nothing but z square upon d by dz of x. What is x? It is nothing but ln z. Okay, this is separate, numerator and denominator. As z square's derivative is 2z, ln z's derivative is 1 by z. So z goes on the top, it will become 2z square. 2z square. That is the answer. 2z square. Very good, Savita, Satyashri. Awesomeness. Proud of all of you. Next question coming up on your screen. Next question coming up on your screen, my dear warriors. All right, all right, all right, all right. Here is the question. Let's see if we can do this. Find the derivative of sine square x. Now, this is the catch. Just some time back, we did sine of x's square. This is sine x's whole square. Completely different. Completely different. This is, sine x's whole things square. What we did some time back was way, way different. Look at this. Where did it go? Somewhere we did it. Not able to find. Here. See, this was sine x's square. That was a completely different problem. Okay. This is completely different. Let's see if you guys can figure this out. Hmm. What do we do? What do we do in this case? You do not know sin x whole square's derivative. You have to use trigonometry. That's why I taught you trigonometry. Let's use trigonometry, my dear students. Let's use trigonometry, okay? Uh, is there some formula for sine square? I think there is. Remember, cos 2x is 1 minus 2 sine square x. Do you remember this formula? Cos 2 theta is 1 minus 2 sine square theta. So what will be 2 sine square x? It will be 1 minus cos 2x. So what will be just sine square x? It will be half minus cos 2x, the whole thing divided by 2. So instead of sine square x, put this. Let's see what happens next. Let's see what happens next, okay? So what do I get is derivative of half minus half into cos 2x. So what I will do, subtraction, that means separate out the derivative of half separately, minus that 2 will also come outside, and just the derivative of cos of 2x. Is that fine? Everyone with me till this point? Cool. Now see, what is derivative of half? Half is a constant. Constant's derivative is always 0, minus half this as it is. Now understand, this is actually ax plus b form. B is hidden. B is hidden by putting a 0. Just look at it. It is ax plus b form. Wow, we know this. Cos's derivative is negative sign, so put a negative sign and that 2x plus b form. Whatever is the coefficient of x, multiplied. So 2 into that. So hence the answer will be negative cancels, 2 cancels. So hence the answer will be basically sine 2x. Hence the answer will be basically sine 2x. 2 cancels, negative also cancelled. Just sine 2x has come up. Yep, sine 2x has come up. And what is sine 2x? We all know sine 2x is basically 2 sine x cos x. 2 sine x cos x. That's the standard double angle form. Interesting, right? Understood? Clear? Let's go. Let's go to the next question coming up on your screen. Let's see if you guys can figure this out. If you solve this question, I will be super duper proud of you. Come on. Very similar question. Find the derivative of cos square x. Find the derivative of cos square x. Do I know some trigonometric formula with cos square? I think I know the double angle formula of cos. The double angle formula of cos. Hint is that use that hint and solve the problem. Come on. Cos 2x was 2 cos square x minus 1. Take that 1 on the other side. So 1 plus cos 2x is 2 cos square x. So just cos square x will be half plus cos 2x divided by 2. So just exactly do that. Derivative of half plus cos 2x whole thing divided by 2. So what do we get over here? What do we get over here? This is just the derivative of half separately, plus that 2 will come outside, it's a constant, and just the derivative of cos 2x. It's actually hidden ax plus b form. It's a hidden ax plus b form. Constant's derivative is 0. Half comes as it is. Cos of ax plus b derivative is minus sine of x. So minus sine 2x plus 0. Okay, perfect. And that coefficient of x comes outside. So 2 into that. So hence 2 cancels. The answer will be minus sine 2x. Minus sine 2x. How many of you got it? Very good. Sir, my comment getting deleted. Wanted to say something. I'm not so sure, Jersey, what you were saying. But see, the admins are very strict in Vedantu. If you spam, if you say something unnecessary, disrespectful, fine, you say teaching is bad, no problem. Nothing. Nobody will say anything. You say, I'm a very bad teacher, no problem. But if you say something, I'm not able to understand, that's fine. But if you say something derogatory against me or any of our teachers or anything against Vedantu, then 100% you will be blocked. Okay? There is no denying that fact. And there is no thing like, not just in YouTube, but even in our platform. Okay, we do not tolerate. There is zero tolerance towards any negativity or anything which is not related to studies. If you unnecessarily try to divulge, that's it. It's very simple. We have a very simple policy. Anything which is derogatory, which is uh, disrespectful, which is not relevant and unnecessarily spam, or which is false, straight away block. Okay, it's not like, okay, we'll see and do and this and that. Very simple. Okay, all right. Jersey, don't spam like that, or else again the admin will block you. You put whatever you have to in one line. Don't put one word, one chat. Again, the admin will block you. Okay, so this is also done. This is also done. Okay, let's see one more question. One more question, my dear warriors. Let's do one more question. D by dx of sine of x by x square. Sine of x by x square. Come on, let's see if you guys can figure this out. Sine of x by x square's derivative. This is a division quotient rule. So what I will do, use the technique. First, take the denominator and square it. Then take denominator and take the derivative d by dx of sine of x minus, then take the numerator sine of x into derivative of basically x square. That's all. That's all. Okay, let's see what do we get. We'll get x square, derivative of sine of x is cos of x, minus sine of x into derivative of x square is basically 2x, the whole thing divided by x raised to 4. So I think we will get cos x by x square minus 2 sine of x divided by x, and x raised to 4 will cancel. I'll get x cube. That's it. So cos x by x square minus 2 sine x by x cube. That is the answer. How many of you got it? Wow, some of you have got it. Very good. Very good. Very good. Very good. Proud of all of you. Now that you have understood it till here, oh, by the way, let's now see the next concept in derivatives, which is useful in some problems, which is the concept of maxima and minima. What is this concept of maxima, minima? Let me tell you that. Okay, and then we'll put an end to this class and we will do integration in a separate class. Okay, so actually the thing is, I thought I will do everything in 2 hours, but then I went slow deliberately because I wanted everybody to understand it properly. So I took up a lot of problems just for your sake. So I thought, why not keep a separate class for integration? Okay with it? Put up a heart. Okay with it? Separate class only for integration? Yeah, let's do that. Okay. So let's see properly now what is maxima, minima. What is this concept of maxima and minima? So what is the meaning of maxima and minima? Jesse, nothing like that. Long line statements are not getting deleted. Don't do all these things. Okay. So, see guys, maxima means the peak of a mountain. Minima means the valley inside a mountainous region. So look at this mountainous region. Do you see there is a peak over here? Do you see there is a peak over here? Do you see there is a valley point over here? Here, here. In fact, there is another peak point over here. These green ones, they are called as maximas. They are called as maximas. They are called as maxima. This is your peak. This is your peak. These valley points, these valley points, these valley points, they are called as minima. Maxima, minima. Now, a lot of people think maxima is maximum, minima is minimum. Let me prove this to you that maxima is not maximum and minima is not minimum. Just imagine this. Just imagine this particular graph. And let's say the graph goes like this. It starts from here, it goes like this, and it ends over here. Okay, this graph ends over here. If I ask you, what is the minimum value of the function? What is the minimum value of the function? Then you will be like this. This is the minimum point. This is the least value. Minimum, I think. two minimums happen. Minimum value of the function, correct? And if I ask you what is the maximum value, then this would be the maximum value of that particular functions in that graph. If I ask you what is the maxima, maxima is here. This is the maxima. If I ask you where is the minima, then this is the basically minima. So minima may not be minimum, maxima may not be maximum. So please get it very straight in your head. Okay. So a lot of people think, these two are the same, but clearly over here, I've shown you the distinction. In fact, think of maxima as the maximum value in this locality. Think of minima as the least value in this locality. Like you have a local gunda. You have a local gunda. Think of it like that. So this is like a local gunda. This is like your local gunda. This is your local gunda over here. Okay, this is your local gunda. Okay, he is a don in this area. But who is the real don? Who is the real don? The real don is your Shreyas Sir. The real don is nothing but your Shreyas Sir, right? Your cap. I'm just putting a cap to show cap. Yes, cap. So that is your capto saying like yo types. Okay. So this is the real don. This is like a local gunda. I hope this is clear. Everybody understood the difference between the two? Great. Now, how do you identify between the maxima and the minima points? Let's come to that now. Let's come to that. It's very straightforward. Okay. So whenever you have a graph, and you are looking at a maxima point or you are looking at a minima point, one thing is common between both of them. One thing is common between both of them, and that is at both these points, if you draw a tangent, the tangent is parallel to the horizontal. So you can see that if I draw a tangent over here, or if I draw a tangent over here, the slope is zero. The slope is zero. So be it maxima or be it minima, the necessary condition, very, very important, the necessary, the necessary condition, the necessary condition is, what is that necessary condition? Dy by dx has to be zero. Okay, the slope has to be a big fat zero. Without that, it can't be a maxima or minima. Before going ahead, first I will check whether you have got maxima, minima, the slope is zero. It's just like if you want to get into government college, what is the first necessary thing? You have to clear the NEET cutoff. Undeniable fact. Just because you have cleared the cutoff, does it mean that you will get a government medical college? No, right? Same way, if you want to see if it is a maxima minima, you will see whether the slope is zero. After that, we can see other conditions. Oh, for government medical college, this. For private medical college, this. So there will be criterias after that. So the next criteria comes over here. So that next criteria comes over here. So the criteria for deciding, the criteria for deciding, like how you decide a college, for deciding a maxima versus minima. Maxima versus minima is as follows. For maxima, the second derivative should be negative. For minima, it's exactly opposite. And the criteria for a minima is the second derivative. When I put 2, it is second derivative. The second derivative should be positive. The second derivative should be positive. Now, what is the meaning of this first derivative and second derivative? Let's probably take it with an example. Okay, let's probably take it with an example. See, imagine if I ask you, example, y is equal to sine of x. If I write dy by dx, it will be like, okay, derivative of sine of x, which is nothing but cos of x. But if I put d square y by dx square, it is the derivative of the derivative. So already I found the derivative. So it is just the derivative of cos of x. So it is minus sine x. I can go a step further and I can find the triple derivative. D cube y by dx square is the derivative of the derivative of the derivative, which is minus common, just the derivative of the sine of x, which is nothing but cos of x. I can go again ahead and I can find any nth order derivative. So another example of second or third order derivative. Imagine, the question is like, y is equal to x raised to 5. Find d square y by dx square. Find d square y by dx square. Okay, that is the question. So first things first, let's find dy by dx. dy by dx is nothing but the first derivative of x raised to 5, which is 5 into x raised to 5 minus 1, which is 5 into x raised to 4. The next step, to find the next derivative, you will find the derivative of this, which is 5 into x raised to 4. 5 comes outside, x raised to 4's derivative, 4 comes outside, x raised to 4 minus 1, which is 5 4s are 20 into x raised to 3. So 20x cube is the answer. 20x cube is the answer. Similarly, if I ask you, come on, find the second derivative of log of x. Find the second derivative of log of x. No issues. Let's find first the first derivative of log of x. The first derivative of log of x is just 1 by x. The second derivative of ln x will be just the derivative of 1 by x. The derivative of the derivative. Take that x value on the top, it will become x raised to minus 1. X raised to minus 1 is x raised to n form. Put minus 1 outside. X raised to minus 1 minus 1. So it will become minus 1 into x raised to minus 2. Bring it down. So it will become minus 1 by x square. So the second derivative of log of x is minus 1 by x square. This is how you find the second, third, fourth, anything derivative. Okay? This is very, very simple. If you know simple derivatives, it's just doing the process multiple times. So the process to find maxima and minima is you just find the first derivative, check, whether dy by dx is 0. And the next criteria, just like how you decide which college I might get, is check the second derivative. If it is negative, it is maxima. If it is positive, it is minimum. It's opposite. A lot of people think minima means negative, positive means maxima. No, it's exactly opposite. Let's take an example to figure this bit out. Let's take an example. Imagine I will take an example. Y is equal to x square minus 2x plus 4. Find if any maxima or minima exists. Find if maxima or minima exists and find those values. Okay, so let's do this. This is some function. What will I first do? I'll check the slope. The slope has to be 0. So that is my first step in that problem. So the slope must be 0. That is the first criteria. So dy by dx, which is derivative of x square minus 2x plus 4. This has to be 0. Okay. So it is nothing but 2x minus 2 plus 0. Correct? Makes sense? X square's derivative is 2x raised to 1. 2 into x. X's derivative is 1 only. Plus 4 is a constant. Constant's derivative is 0. So hence, I will get 2x minus 2 is 0. Solving this further, take that 2 over here. That is 2x. Therefore, x is equal to 1. What it tells you is the slope is 0. The slope is 0 at x equals to 1. It could mean both of these things. Either it is like this 0 or it is 0 like this. Now, I don't know whether it is a maxima at 1 or minima at 1. Both the cases, I know that answer will be 0 if I find the slope. So, to decide whether it is a maxima or minima, what I will do is do the next step. So, the next step of the problem is second derivative. So, d square y by dx square. Do you see this was the first derivative? If you notice this particular thing, this itself was your dy by dx. This was your first derivative when I found it out. So you have to take the derivative of this. You have to take the derivative of 2x minus 2. 2x minus 2. Okay. What is the derivative of 2x minus 2? It will be 2. X's derivative is 1. So 2 into 1. Constant's derivative is 0. The best answer that I get is 2. Oh, interesting. This 2 is positive. If it is positive, means you don't even have to check anything. You don't even have to do anything. If the answer is positive, it implies it has to be a minima. The only thing which is there in the problem is a minima. There is no maxima only in the question. So hence, there is a minima at x is equal to 1. We found the point, but where is that point? At x is equal to 1. Got it? Everybody with me? Exactly. Let's take one more question so that you guys understand it properly. Let's take one more question so that you understand it properly. Let's say the question goes like this. Y is equal to x into x minus 1 into x plus 1. Okay, this is the question. Okay, and I want to find if there are any maximas or minimas in this particular graph. Okay. Now, first things first, there are many terms over here. So maybe first thing I will do is expand it before doing anything. So therefore, I'll just expand it. So it will be x into a plus b, a minus b is a square minus b square. So x square minus 1 square. And multiply it further. X into x square is x cube. 1 into x is just x. So this is the actual function. This has been factorized into these three factors. That's all. Okay, perfect. So let's just find the first derivative. So dy by dx, how much will it be? It's just the derivative of x cube separately and subtract it with the derivative of x. So x cube's derivative is 3x square. X's derivative with respect to x is 1. Also, simultaneously, let's find out the second derivative, d square y by dx square. So you just have to find the derivative of 3x square minus 1. So it will be nothing but 3. X square's derivative is 2x minus 1 is a constant, so derivative is 0. So it is basically 6 times of x. So this is your second derivative. Oh, this could be positive or negative, depends on many factors. So do you see that? It could be positive or negative, depends on the value of x. So I do not know that yet whether it is a maxima or minima. Okay, no issues. Let's continue over here. Imagine for it to be maxima or minima, the essential condition is this dy by dx must be 0 for the maxima or minima. This is the most essential. This is necessary condition. This is necessary condition. So if I rearrange it, 1 will be equal to 3x square. That means x square will be 1 by 3. That means x will be plus or minus 1 by 3. So two values are I am getting 1 by 3 and minus 1 by 3. At one of these points, maybe there is maxima. At one of these other points, maybe there is a minimum. But I know at 1 by 3, slope is 0. Minus 1 by 3, slope is 0. So at these 2 points, the slope is 0. Everybody with me? Everybody understanding it till this point? At 1 by 3 and minus 1 by 3, the slope is big fat 0. That is what this is telling me. That is what this is telling me. Okay. So what I will do now, I will substitute both these values over here. I'll substitute 1 by 3 here, and I'll substitute minus 1 by 3 over here, and see what is the value of the second derivative I'm getting. 6 into 1 by 3, 6 into 1 by 3 is basically 2. 6 into minus 1 by 3 is minus 2. This is positive, this is negative. It is very, very clear now what is happening. Negative means maxima. So there is a maxima, at x equals to minus 1 by 3. Also, I get to know, because this is positive, there is a minima, at x is equal to plus 1 by 3. Don't worry about these values. These values are nothing. Just you have to check the sign of it. This is 1 by 3 minus 1 by 3 are those values of x at which I'm getting maxima and minimum. All we did was check, okay, this was more than 0, this was less than 0. That's how you find maxima and minima. Clear? So a lot of you said 2 and minus 2, guys. 2 and minus 2 is not maxima. Please get that right. 2 is not maxima, minus 2 is not maxima. That is the value of the second derivative. Second derivative's value is what I'm getting. You just need to check whether it is positive or negative. If it is positive, the value that you have substituted is the location where you get the minima or maxima. Got it? So that is a common mistake which many students do. That is the reason why I did this question. All right. So now I hope you have got that confidence. I hope you have got that confidence in derivatives and integration. Sorry, integration, we'll be doing it in a separate class. So I hope you are guys confident in derivatives. I want everybody to put that up. I want everybody to put that up in the comment section. Confident in derivatives. In derivatives. Everyone. Okay. If you're confident in derivatives, put it up, like the session, and also subscribe to the channel, and eagerly wait for the next class on integration separately. Okay. I've covered everything, whatever is needed, my dear students. Maxima, minima, slope, second derivative, your function by function, function into function, cos square, sine square. These are basically called parametric forms. Even if you don't know the name, it's okay. But these kind of substitution questions, addition, subtraction, all the things, rules we have done in this particular class. Okay, so this was a beautiful detailed class for anybody who wants to study from YouTube as well. Okay, so please share this video with any of your friends who is finding derivative stuff. After this, they will be like, "Arey sir, derivatives is actually simple only in the physics part. Wherever I need to use it, that physics part I need to understand, then I can combine both of them together and solve the question." So that's it, guys. Okay, thank you so much. Have a great day. Lovely seeing all my lovely warriors. Very good. Great job, Krishna, Savita, Murli, Satyashri, Abhishek. Awesome. Okay, put it up in the comments. Okay, after the video is over.